A very powerful tool for solving quadratic equations is called the quadratic formula, which we'll go into in a different lesson, but I need to mention it here because we're going to talk about just one part of it. The solutions of the quadratic equation in the form ax squared plus bx plus c equals 0, so that's standard form, where a does not equal 0, because if a equals 0, we have a linear equation, not quadratic anymore, can be given by the quadratic formula. Okay, x equals negative b plus or minus, here's what we're interested in, the square root of b squared minus 4ac all over 2a. That little bit under the radical has its own special name. It's called the discriminant. The value of the discriminant can be used to determine the number of real roots for a quadratic equation, or help determine or discriminate between the different roots. Your worksheet is formatted in a very friendly way where it's already all in standard form. So it's going to be easier to identify. A is 12, B, the coefficient of x is -1, and C, the constant, is -6. And so we can plug and chug into our formula. All we need from the formula is the b squared minus 4ac. So -1 squared minus 4 times 12 times -6 is 289. Now when I checked on my calculator, wouldn't you know, the square root of 289 is exactly 17. And -17 times -17 is also 289, so we have two answers. So on your worksheet, we would call this one 2 different rational roots, because square root of 289 comes out even. I'm sure you're guessing where I'm going with this next one. If we plug into the formula b squared, so -12 squared minus 4 times a times c, I'm going to get 12. 12 is not a perfect square, so if I went to take the square root of 12, I could simplify the radical, but it's still going to be irrational. And this time when we find the discriminant, we've got -8 squared minus 4 times 1 times 16 happens to be -8 times 8 is 64, and wouldn't you know, 4 times 16 is also 64. What happens when you take the square root of 0? Well, not much. It stays 0. And if you add or subtract 0, you get 0. So if we get a discriminant of 0, we're only get one rational root. It's actually a double root. We kind of mentioned that already. What else can there be? Well, one last way it can happen. If we do -8 squared minus 4ac, we get 64 minus 84, which is -20. If I try to type square root of -20 in my calculator, I get a message that says domain error. There are no real numbers multiplied by themselves that equal -20. So this is our situation where we have no real roots. Here's a summary. If we have a negative discriminant, we get no real roots because the graph will never cross the x-axis. If we get a discriminant of 0, we get exactly one real root because it's a double root. The parabola will just touch the x-axis. And if we have a positive discriminant, we will get 2 roots. Now, if they are perfect squares, they are rational. If they're not, then they are irrational, such as this guy, definitely irrational.